You ever notice those little ponds or grassy dips next to a new shopping center or apartment complex? Well, they're not just for looks. They're actually a super critical piece of kind of invisible engineering that's protecting our towns and cities every single day. So today we're going to pull back the curtain on the hidden science of stormwater management.
It all kicks off with one big question. Why is it that when we build something new, a parking lot, an office building, pretty much anything, it suddenly creates this huge risk for flooding? Well, the answer is all about what we're covering up.
Okay, so the core problem here is actually pretty simple. I want you to think of natural ground, like a field or a forest, as just a giant sponge. When it rains, it soaks up a ton of water. But when we pave over that ground, we're basically swapping out that sponge for a hard, non-absorbent plate. And now that water has absolutely nowhere to go but to run off. And it runs off really, really fast all at once. And that sudden rush of water, well, that brings us to the single most important term in this whole field, peak flow. This is the metric that engineers live and breathe by. It's the maximum gush of water pouring off a site during a big storm. You can imagine it like cranking a faucet on full blast, that absolute maximum rate. That's the peak flow.
This leads us to the fundamental, non-negotiable rule for any new development. And it's this: you are not allowed to make flooding worse for your neighbors, period. The peak flow of water leaving your site after you build has to be the same or even less than it was when it was just an empty field. That right there, that's the engineer's mission.
So how in the world do they pull that off? Well, the very first step is to set a baseline. Before you can even think about designing a fix, you have to know exactly what problem you're trying to solve. You've got to measure the before so you can set the target for the after.
And engineers, they don't just guess. No way. They build these really sophisticated computer models using real-world data. They map out the existing ground, they study rainfall patterns for that area, and they use this model to find the exact compliance point. That's the specific spot downstream where their design success is going to be measured. It's all about creating a solid, data-driven starting point.
So, after running the simulation on the natural, undeveloped land, we get our magic number. In this case, it's 70.24 cubic feet per second. That is the speed limit, the absolute max. Any design for this new development cannot, under any circumstances, release water faster than this. This number is now our goal. It's our target.
All right, so we've got our target. The next logical step is to model the brand new development, but, and this is key, without any of the safety features. This is how we figure out just how big of a problem we're really dealing with.
And yep, the results are usually pretty dramatic. The model shows that with all that new pavement and all those new rooftops, the peak flow just skyrockets. It becomes way higher and way more dangerous than our target. This confirms that if we just built it as planned, we would absolutely 100% cause flooding downstream. This is the digital proof of a disaster waiting to happen.
Okay, so we have a really big problem on our hands. How do we fix it? Well, this brings us to the engineer's #1 tool for the job, the detention pond.
A detention pond is basically just a big engineered bathtub. Now, its job isn't to hold water forever. No, it's designed to capture that initial dangerous rush of runoff from that plate we just created. It holds on to it for a little while and then lets it out slowly, safely, and at a rate the downstream pipes and streams can actually handle.
But designing one of these isn't just guesswork. It's a really precise 3-step process. First, you calculate exactly how much water that pond needs to be able to store. Second, you figure out the shape of the pond based on the land you have to work with. And third, this part is absolutely crucial, you design the outlet, the drain, that's going to control exactly how fast that water gets released.
And I really love this point from the source material. While these computer programs give a great starting point, the whole thing isn't just automated. The engineer has to use their judgment, their real-world experience, to add a safety buffer. Why? Because the real world is always way more complicated than a computer model. It's this perfect blend of hard data and human expertise.
And now it's the moment of truth. We've identified the problem, we've designed our solution, the pond, and we've built it into our computer model. So it's time for the final check. Did our design actually work? So we've run the simulation again. This time, it's with our proposed development and our brand new detention pond. So what's the verdict? Did we succeed? And here it is, the payoff. This one chart tells the whole story. See that first bar? That's our target, the natural site's peak flow of 70.24. That second towering bar, that's the disaster scenario, the development with no pond. Whoa. And that third bar, that's our final design with the pond included.
And look at that. It's right back down at our target level. It's perfect.
And there you have it, success. The engineering design worked like a charm. By catching that first big surge of water and letting it out slowly, the detention pond brought that dangerous peak flow right back under control. And that protects the entire community from flooding.
And this really is the fundamental principle. It's the ultimate success metric for this whole process. The flow of water after you build must be no greater than the flow before you built. It's the golden rule of stormwater engineering.
It really makes you think, doesn't it? The next time you drive past one of those ponds, you'll know it's not just a water feature. It's a super carefully designed safety device, which kind of begs the question, right? What other invisible engineering is quietly working all around you, keeping your city safe and running every single day?